Quantum levitation. Earlier to this video, few videos were posted in the same channel, and the subject matter was almost the same. Here in today's topic is quantum levitation, because the effects of quantum mechanics is there in case of levitation, and similarly there is acoustic levitation also. Okay, so here we are talking about only quantum levitation. So in the chapter of superconductivity, or in the subject of superconductivity, you will find this topic, quantum levitation. So what is that thing? This quantum levitation, this is also known as flux spinning, or this is also known as quantum locking. So many names are there. Again, magnetic levitation, this term is also used. Okay, so today's topic is quantum levitation. When means certain materials are there. Okay, not all materials. Certain materials are there. If those materials are cooled below a critical temperature. Critical temperatures are different for different materials. Okay, I am not going to discuss anything about critical temperature here. You just keep in your mind that there is one critical temperature for each material. This temperature is different, but for any material it is a fixed temperature, which is known as critical temperature. So whenever certain materials are there, if they are cooled below critical temperature, then the phenomenon of superconductivity occurs. That means that material becomes a superconductor. That means it becomes a conductor with zero electrical resistance. Means there is no resistance at all. There will be no resistance at all if the material is cooled below a critical temperature. Its critical temperature, not a critical temperature. Okay, because the critical temperature is fixed for any given material. Anyway, so when zero electrical resistance is there, means in the presence of zero electrical resistance, the material becomes a superconductor. Means electrical current can flow without any resistance, and in that case Cooper pairs form. That means Cooper pairs is what? It is the pairs of electrons which can move through the material without scattering. Okay, so there are so many points. First point is it becomes a superconductor. So whenever it becomes a superconductor, it can expel the magnetic flux from its interior when there is one external magnetic field applied. Okay, if external magnetic field applied, then in that case that magnetic field penetrates through the superconductor material. Okay, but when the state of superconductivity is achieved, in that case from the interior of the superconductor, okay, from the interior of the superconductor, the magnetic flux, there is an expulsion of the magnetic flux, and this effect is known as Meissner effect. There is one video Meissner effect in my channel that was posted few months back. Okay, anyway, you should study all those types of videos, or you should study all those topics to gain knowledge in this topic, quantum levitation. Okay, so there is the effect of Meissner effect. Okay, means there is application of Meissner effect in case of quantum levitation, and levitation occurs due to this expulsion of the magnetic flux. Then there is quantum locking and flux spinning. If defects or impurities are present in the material of the superconductor, then magnetic flux lines get locked in position, and due to this effect you will achieve stability. Along with levitation, for the development of technology, stability is also required, and that stability is achieved by this flux spinning. Okay, then there is again quantum locking. When flux spinning becomes stronger, if it reaches to a high limit, then in that case quantum locking occurs, and which is also responsible for the stability. And there are so many applications of this quantum levitation technology, such as MRI, means magnetic resonance imaging. Okay, then maglev trains are there, means magnetic levitation transportation systems. In those cases also this quantum levitation, okay, this concept is used. So there are so many areas where, again, in case of frictionless bearings, quantum levitation can be used. So many technologies are there, and many technologies are being discovered by engineers and scientists. Okay, researches are still going on in the field of superconductivity. Okay, and so many things are there. Means this is a subject of ongoing research. Okay, anyway, so this was all about quantum levitation. Just keep in your mind that this quantum levitation, this is also known as magnetic levitation, this is also known as flux spinning, this is also known as what? Quantum locking. So many terms are used for the same effect, but the main thing is due to which this magnetic levitation or the quantum levitation is achieved, that is Meissner effect. So you should study in detail Meissner effect to gain knowledge in this field. Anyway, so this was all about today's lecture on quantum levitation. Okay, thank you for watching this video.